Now I discuss the topic about equivalent weight. What is equivalent weight? Equivalent weight of an element is nothing, only it is atomic mass or atomic weight of the element divided by its valency. That is called equivalent weight of a substance or element. Now the main thing is same, but it will change for substance to substance, or it is different for substance to substance, because valency will be changed for each element or each compound. You know, the valency is the actual number of electrons are transferred. Okay, now for acid it will be different, for base will be different, for salt it will also be different. Actually the equivalent mass or equivalent weight of any substance is nothing but only the atomic weight or the molecular weight of the substance divided by the number of electron transfer. Okay, suppose here I calculate some, then it will be clear. Now first of all, I will discuss that equivalent weight of an acid. Equivalent weight of an acid. What do you mean by equivalent weight of an acid? See in the down of the book or bottom of the book, the equivalent weight of an acid is the molecular weight of acid. See, the equivalent weight of an acid means the molecular weight of the acid divided by the basicity of the acid. You know, the basicity of the acid means the number of electron transfer. So suppose you see that for HCl, we know the molecular mass of HCl is hydrogen 1 and chlorine 35.5, and you know HCl dissociate in its aqueous solution as H plus Cl minus. So number of electrons transferred, that is 1. So what will be the equivalent weight? That is 36.5 divided by 1. So equivalent weight is also 36.5. But in case of H2SO4, we know the H2SO4 will dissociate as H2SO4, that is equals to 2H plus SO4 2 minus. That means 2 hydronium ions or 2 hydrogen ions are produced. That means 2 electrons are transferred. H2SO4, the molecular weight is 98 and number of electron transfer, that is 2. So that's why 98 by 2, 49. Similarly for H3PO4, here 3 H plus ions are produced. Molecular weight is 98, but you have to divide it, that 98 by 3, that is 32.67. Clear? Next, equivalent weight of a base, that molecular weight of the base divided by acidity of the base. Acidity of the base means similarly the number of electrons are transferred. Now you see that calcium hydroxide, NaOH is simple, that NaOH 40 and only 1 ions are produced. That means only 1 OH minus ions are produced, or only 1 electrons are transferred. That's why 40 divided by 1, that is 40. Now calcium hydroxide, that is 74, the molecular mass, and Ca2 plus 2 OH minus, 2 electrons are transferred. That's why 74 by 2, that is 37. Okay. Now I'll discuss some of the equivalent weight of a oxidant or reductant. Oxidant or reductant means it will be discussed in later in the redox chapter. Okay, that is formula mass by the number of electrons gained or lost by one molecule. That is the equivalent weight of an oxidant or reductant. Equivalent weight of an oxidant or reductant means formula mass by number of electrons gained or lost by one molecule. Okay, you see First of all, I'll discuss about K2Cr2O7. See the reaction Cr2O7 2 minus plus 14H plus 6 electron, arrow 2Cr3 plus 7H2O. This is the redox reaction. Okay, this is a redox reaction. This kind of reaction will be discussed in the redox chapter later. Now the formula mass is 294. You see that how many electrons are transferred? 6 electron. So 294 as of earlier formula, 294 divided by 6, that will be its equivalent weight or equivalent mass. You see the number of electrons gained or lost by one molecule, that is 6. The equivalent weight is 294 by 6, so 49. So 49 is the equivalent weight of K2Cr2O7 potassium dichromate. Now KMnO4. In the first KMnO4, you see that MnO4 minus plus 8H plus 5E, here 5 electrons are transferred. So KMnO4, the molecular weight is 158, and you see the number of electron transferred is 5. So 158 by 5, that is 31.6. Okay. Now in the second case, KMnO4 is, here KMnO4 transfer 3 electron. Okay, 3 electron, MnO4 minus plus 4H plus 3 electron. So formula molecular mass is same 158, but only the number of electron transfer, that is 3. So 158 divided by 3. So 158 divided by 3, that will be 52.6. So the equivalent weight of KMnO4 in this case, second case, where number of electron transfer is 3, that is 52.6. Clear? Now you see the last one. FeSO4, it is not so much critical. Here only one electron transfer, so that's why it is clear. But you see the H2C2O4 dot to H2O. So see the formula, C2O4 2 minus, arrow 2CO2 plus 2 electron. Okay, so here the number of electron transfer, that is 2, and the molecular mass of the substance is 126. You see the molecular mass or formula mass is 126. So here 2 electron transfer, so it is quite easy to calculate the equivalent weight. So 126 divided by 2, 126 divided by 2, so equivalent weight is 63. Okay, so today up to this, the concept, I think it is clear. Okay, the class is end for today.